Hello everyone. In this video, I will be discussing Learning Objective 4 of Week 10, Factor Analysis. In the last three videos, we have discussed dependence techniques of multivariate analysis, multiple regression and discriminant analysis. In this video and the next one, we will be discussing interdependence techniques. So we will be discussing here factor analysis, and in the next video, we will be discussing cluster analysis and multidimensional scaling. So these factor analysis, cluster analysis, and multidimensional scaling, they are interdependence techniques. So you will be using one of them when you have multiple variables and there is no dependence-independence relationship. That means among the variables, you cannot find out if there is any dependent variable or independent variable. Rather, if the variables are such that there is interdependence, then you will use this one of these interdependence technique. So first of all is factor analysis. So factor analysis is a technique that statistically determines or statistically reduces a large number of variables into some factors. Okay. For example, sometimes it's possible that you have hundred of variables. Now you understand, if you run a regression or other statistical tool with 100 variables, then explaining the result in a sensible way is very difficult. So factor analysis will reduce these 100 variables into some factors that will represent them as a group. Okay. Then I will show you an example. There are two types of factor analysis. One is exploratory factor analysis, another is confirmatory factor analysis. Exploratory factor analysis is used when you do not have very good knowledge about the factors that you might have. Okay, that means let's say you have 100 variables, but you don't know some overall factors that can cover these 100 variables. And you are uncertain that how many factors are there, then you will be using exploratory factor analysis. And confirmatory factor analysis is used when you have a theoretical expectation about how many factors there can be. Now let's take an example that will clarify the factor analysis. Suppose a researcher is asked to examine how feelings of nostalgia in a restaurant influence customer loyalty. 350 customers at themed restaurants around the country are interviewed and asked to respond the following Likert scales. So you understand, it's actually a survey where customers are asked 8 questions about whether their feeling of nostalgia influences their loyalty to a particular restaurant. So what they're asked is, look, I feel a strong connection to the past when I am in this place. This place evokes memories of the past. I feel a yearning to relive past experiences when I dine here. This place looks like a page out of the past. I'm willing to pay more to dine in this restaurant. I feel very loyal to this restaurant. I would recommend this place to others. I will go out of my way to dine here. So these 8 questions are asked, and each has a Likert scale from 1 to 7. 1 is a strongly disagree and 7 is a strongly agree. Now, if you carefully look at these questions, although there are 8 questions, but we can identify 2 major factors. For example, first 4 factors, the first 4 questions, like I feel a strong connection to the past when I am in this place evokes memory of the past, or I feel a yearning to relive past experiences. This place looks like a page out of the past. So you can say all these are related to nostalgia, all these 4. On the other hand, I'm willing to pay more to dine. I feel very loyal. I recommend this place, or I will go out of my way to dine here. These 4 are related to loyalty. So what we can do is these 1, 2, 3, and 4, these 4 variables can be grouped as nostalgia, and 5, 6, 7, and 8 can be grouped as loyalty. Okay, now what factor analysis actually does is factor analysis provides you some loadings. That loadings will identify which variables belong to this factor. For example, if you look at factor 1, factor 2, and in factor 1, look at these loadings for x1, x2, x3, and x4. So these loadings are pretty much higher compared to the loadings of these four. So you can see these four variables actually belong to one particular group. And if you look at these 4, 5, 6, 5, 6, 7, and 8, 0.9, 0.9, 0.75, and 0.72, that means these four variables belong to another factor. Okay, so in this way, in using factor analysis, if you have large number of variables, you can statistically reduce them down by to some factors that will represent a group of variables. So this is the end of this this is the end of this video and our discussion on this learning objective. So please watch the next video to understand our learning objective 5 of this week. Thank you.